Welcome to the 19th webinar on clean fuel and lubricant solutions from the Donaldson Company. In this webinar, we're going to talk about your return on investment for protecting your equipment with clean solutions as it relates to diesel and hydraulic applications. Our outline objectives are going to be best practices to meet or exceed your OEM specifications for diesel fuel and hydraulic fluids, calculating return on investment for improved fuel and lubricant infrastructure, and lastly, market trends in diesel powered equipment. So your hosts today are Jim Doyle and Paul Click.
And this is Jim Doyle. We'll get going with best practices for diesel fuel. The advancement in technology in the high pressure common rail fuel system is significant. The tolerance for dirt in diesel fuel, in diesel engines, is basically gone. Virtually all particulate needs to be removed from diesel fuel at this point. Particles as small as 2 microns will do damage, as you see in these images here. Hard particles trap in this portion of the fuel control portion of the injector, and they dent and dimple the surface, the 2 mating surfaces of the valve, and leakage across that valve seat begins. Particulate needs to be, virtually all particulate needs to be removed, and injector manufacturers have come up with a specification of Cleanliness Code of ISO 12996 or cleaner to make sure this damage does not occur. Leakage of as little as 1.5% will cause these components to be considered fail.
So on our Clean Diesel YouTube channel, you can find more information on this specifically and goes into detail. But it's enough to say that, in the 80s and 90s, we were doing 8,000 psi injection, and new engines are doing 40,000 psi injection. So the tolerances are much tighter, and the fuel needs to be much cleaner.
The industry, when these types of fuel injection systems were being first released into the market and developed, came up with a position statement to describe and to handle the new requirement for cleanliness fuel and how things need to be kept in order to maintain warranty and proper operation. The takeaway from that is that it's the responsibility of the equipment user to ensure that fuels are compatible with the fuel system, and by that they mean cleanliness.
So as you might know, there's a fuel spec, an ASTM fuel spec. Most people attribute D975 for fuel quality, and what this position statement is effectively saying is that regardless of the ASTM spec, which is, for all intents and purposes a little outdated for these new engines, it's up to the end user or the fuel supplier to clean that fuel to ensure that there's no downtime events due to fuel quality.
So how do you get to be operating at this sort of new level of cleanliness overall? If you just continue to do what has always been done, you're likely to have issues. There needs to be a significant change in handling practices and behavior to get there. And we've come up with a simple strategy called clean, protect, and polish to get your fuel as clean as it needs to be, make sure it's as clean as it needs to be before you need to use it so that you have time to react if there is a fuel issue, and to maintain operability. That's done by cleaning the fuel when you take possession of it, if possible, so offloading from a fuel truck into your tank infrastructure, if you do own your fuel infrastructure. That gives you the most time to react to an issue and to detect fuel quality issues that might impact your operation at the time you're taking possession of that fuel. You're buying the fuel off of the fuel truck, and it's yours as soon as it's in your system, with no real significant quality test there at the time it gets transferred into your system. So putting that into clean fuel tanks, make sure they're clean to start with, not 15, 20 years and never been maintained. They should be clean to start with. Put a breather on that tank so outside debris does not enter the system when liquids are pumped out of those tanks, and to polish that fuel on the way out, basically going through the same level of filtration that was on the inlet side on the outlet to ensure your fuel is very clean and should not cause operational issues.
So in summary, there's 3 types of contaminants, three categories: hard particulate, water, and insoluble chemistry in the fuel. And if you approach your fuel infrastructure in this sort of manner, you can effectively eliminate those issues from ever getting on engine in the first place.
So the needed filtration results, just to sort of go over what things typically look like and what you need to achieve. This is a fuel sample that's out of a small 500-gallon tank that was actually sitting out in a parking lot for a couple of years, and just parking lot dust blowing around, getting into that tank with very little fuel usage out of it. Wound up with a ton of fine particulate in here. We don't want to get into the full description of an ISO cleanliness count, but this is not an unusual fuel quality for fuel as people have historically maintained it. And the new standards are to be clean enough for your fuel injector. Virtually all of that particulate needs to go away. You need to remove that with filtration. Typical dispenser filtration that exists in the marketplace at, say, the bulk level at 30 microns will remove almost none of that particulate. It will just pass right through the filter and it will last forever. All of that work needs to be done by a filter somewhere, and it's best to not leave that all the way to the secondary filter on the engine system. So now on to best practices for lubricants. There's been a lot of technology development and system design changes over the years that require cleaner fluids, and just assuming that fluids are clean on delivery is not the best way to maintain clean fluids in your hydraulic system and in your gearboxes. So gearboxes, if you run dirty, they typically can run very dirty, and if they're an older gearbox or rear diff, there may be no filtration on there whatsoever, or very coarse filtration, and it is not maintaining a cleanliness level of that fluid that will prevent wear and damage eventually. You can essentially stop wear and damage if you clean that fluid up properly. Probably the most sensitive components in your hydraulic circuit, nearly as sensitive as your high pressure common rail fuel injection system, would be servo valves, control valves on equipment. There's very tight tolerances in the spool there, and you need to maintain cleanliness so that things can slide and move properly for good control.
So for decades, the hydraulic circuit was the most critical circuit for filtration cleanliness because of the pressures. So, averaging anywhere from 3 to 10,000 psi working pressure, that fluid needs to be extremely clean for tight tolerances and removing any of that foreign contaminant.
So the theory and the method is similar for lubricants as it is to fuel. However, there are some significant differences. You generally need, at ambient condition, oils, hydraulics fluids, and engine oils, gear oils are quite thick, high viscosity, and you may need to put much larger filtration than you would for a similar flow rate or volume of fuel, just due to that viscosity change. And you need to select the correct level of filtration to achieve the cleanliness targets that are specified by OE manufacturers.
So when we size filtration, and we have another WebEx on that, so we're not going to get into it, but when we size fuel filtration, typically we size it based on flow rate and quantity of volume used. When we size for lubricant filtration, we really have to look at the viscosity change because it's so dramatic. And in this case, you're seeing an I-12 manifold, which would typically do 600 gallons per minute on diesel, but might only do 30 to 80 gallons per minute on heavy cold engine oil.
Similar to the fuel situation, putting that clean lubricant into a clean tank and protecting it with a proper breather. Here's a trap breather that keeps particulate as small as 3 micron out of the system and helps manage water. And then filtration again on the outlet side. This is a low pressure, higher flow dispense set of hose reels off of a lubricant farm. That's fine for pressures up to, say, 350 psi of pumping pressure or shutoff pressure. But more common in the lubricant side of things are stick pumps, and those are high ratio air pumps, 3, 4, 5, 6, or 10 to 1 air pumps, and you can get pressures in operation or at steady state of 1,000 psi, and you need a higher pressure filter.
And as a kind of a safety note, due to thermal expansion, where oil increases in pressure due to higher temperatures, it's recommended for these outlet systems specifically that thermal relief valves are installed.
Yeah, that's now a requirement by virtually every manufacturer of those style of pumps. It's a pretty common issue with those systems. So this set of filters there on the upper right, the black cans you see there are designed for 1,000 psi service with a 2250 psi burst pressure. So they're suited for that application. And if you get the chance to design a system from scratch, you may be able to incorporate all the best practices that we've covered here into one system and do it very cost effectively and neatly. This is a set of tanks, lubricant tanks at a repair facility. They've used a dual head to not only filter oil coming in with just those two filters into that tank. With just switching some valves, you can recirculate that tank. Notice they are cone bottom tanks as well, which means there's nowhere for debris to collect. All the debris is going to settle to the bottom of that cone and be pumped directly to the filters, meaning the tank stays clean all by itself. You'll notice there's a trap breather, a small industrial trap breather on the top of each of those tanks to protect it from water ingression and particulate. And with just a switch of some valves, that same pump and filters can actually do the filtration on the way out. So that does all the best practices all in one very simple, compact system there. And the question of kidney looping comes up with lubricants. It doesn't really come up with fuel. Typically, high volume fuel users are not holding on to a large volume of fuel long enough to kidney loop it to do filtration. It's much better to do it at transfer into the tanks and then out as you dispense into equipment. But lubricants, it's a recommended best practice by many of the OE folks, and it's sort of across the industry, that people like to kidney loop a tank. You need to turn that tank at a flow rate high enough to actually stir the dirt around. As I mentioned on that previous slide, getting the dirt to the filter is how you get the fluid clean. If you run too slow a flow rate in a tank, you will not turn the fluid over enough to get the dirt to come to the filters, and you'll have a hard time getting the tank clean. So provided you're at a proper flow rate, 5 to 7 turns of that tank will give you a decent chance of getting that tank down to the cleanliness target that you're trying to keep. And then, is your diesel fuel or hydraulic engine oil clean enough? This is just another depiction of the cleanliness codes that are common across the industry. So as we mentioned, I showed that dirty fuel sample earlier. Here's another sample of a similar contamination level of about a 22, 21, 18. That is about the dirtiest fluid, fuel or oil you're even allowed to put into anything, and that's basically low pressure hydraulic, say cylinder operation. If it was that dirty, you may not be doing damage, but you're really on the outside there. That needs significant filtration. 2018-16 is pretty average fuel cleanliness, and that's still too dirty to be running in most any applications. 18, 16, 13 is typically the max contamination that most OEs spec for even engine and gear oils. 16, 14, 11 is common target for hydraulic circuits, transmissions, that kind of thing. And again, fuel circuits need to be very, very clean. You basically have to remove all particulate, and you're down to an ISO code level of 1296. So you can see the dramatic reduction in contamination there. And the higher the pressure of the system, the cleaner the fluid needs to be.
So we're going to kind of change gears. We kind of highlighted a lot of the fuel, what's changed and how clean things need to be and what fails when the fuel's dirty, and same thing for hydraulics. And we're going to talk about the value of adding filtration. So obviously every time you make a change, it's going to take time, energy, resources, and you have to justify of making those changes. So the value proposition, what we're looking at is reducing the operating expense, reducing downtime, ensuring against supply problems, keeping your infrastructure clean. One example of that that's really easy to wrap your head around is a tanker truck of fuel is anywhere between $25,000 and $30,000 investment. And when you take possession of that tanker truck of fuel, it's the end user's problem. So it's ensuring that fuel that makes it into your infrastructure is clean and dry and free of contamination. allows you to get that lowest total cost of ownership for your equipment, making sure that they're running at peak performance, peak efficiency. Some of the signs that you're having fuel quality problems are your filters plug prematurely, a loss of horsepower, multiple regens, your fuel economy might go down, and then lastly, your engines might be throwing codes. And so what we're trying to do here is just meet or exceed the OE fluid recommendations. We believe that the best return on investment is your diesel, and if you're using hydraulics, mobile hydraulics, number two is hydraulics, and that's just a function of the pressure that they're operating at. So every OE has different cleanliness recommendations that we showed visually on the patch test in the previous slides. Most of them are around 18, 16, 13. Some of the higher pressure hydraulic circuits you get into the 16, 14, 11s. Typically servo valves was the highest pressure for decades at 15, 13, 10. And then now with the high pressure common fuel rail, they're asking for a 12.96 at the injector, which is effectively too clean to measure. So as the tolerances get tighter, as the pressures get higher, the filtration needs to be tighter. They say for the new injectors, if you take the injector apart and you hold them in your hand, the heat from your hand is enough to expand the metal such that you can't put it back together again. So we're talking about 2 micron. That's the size of a bacteria. So we saw in a couple images about the gearbox failure. How do those failures occur? 70% of those failures occur due to surface degradation. What that means is you have 1,000 particles in the system that were maybe added in there because the hydraulic, the diesel, or the oil wasn't filtered before it was added. Those 1,000 particles enter in that system and cause more physical degradation of the surfaces in there, and those 1,000 become 1,000,000, those 1,000,000 become 1,000,000,000, and then all of a sudden you have failure at typically the lowest, tightest tolerance location. So we did some running the numbers, and if you take a pump running at 25 gallon per minute, if you add in oil that's 22, 21, 18, it represents 600 pounds of dirt running through that pump over the 6-month time frame. Now it's not truly 600 pounds of dirt, it's just the equivalent of 600 pounds of dirt seen that pump seen, and with proper filtration, getting that down to a 16, 14, 11, for instance, we can drop that 600 pound equivalent down to 5 pound equivalent in that same time frame.
And it'll do less wear and less damage.
The NORIA life extension table, it means that your components are going to last longer, and it's a several factor, 2, 3, 4, 5 times longer. And then now we're going to talk about some market trends in diesel specifically. So this is an article from 2014 published by Heavy Duty Trucking Magazine, and it physically points out that the majority of maintenance spend is coming on the new high pressure common fuel rail circuit and fuel pumps. And we see that in North America alone, it's a $3 billion a year business, and globally close to a $10 billion a year business. So if what we're trying to do is make those bars lower by pre-filtering the diesel before it goes on the engine in the first place. We're also hearing from our customers that the average injector repair is costing anywhere between 8 and 10 grand, depending on the number of injectors and the downtime. But more importantly than that physical cost of doing it is sending a second truck to finish a job, a second crew. A lot of our over-the-road transportation people get paid on on-time deliveries, and when you don't do that, you're hitting your bottom line. And then rental companies, sending out a second truck or having effectively more trucks in your parking lot that aren't being fully utilized.
So just to recap again, it was to cover the best practices to meet or exceed your OEM specifications for diesel fuel and hydraulic fluids. I think we covered what's typical out there is far too dirty to meet those targets, and practices need to change if you've got new equipment to make sure you're on those targets. A little bit of discussion on the cost of doing things and the various things that need to be considered when calculating the ROI for improving the uptime and operability of your equipment. it comes into improving your fuel and lubricant infrastructure is a big benefit. And then just a little bit about the trends in diesel-powered equipment. There's really no going back to old ways of handling practices and expecting to have good operability outcomes.
Well, thanks for attending this WebEx and our YouTube channel. If you want to learn anything more about diesel fuel for new engines, go to mycleandiesel.com. Everything you need to know is there under the Resources tab. On the bottom of the page, you can stay connected with us by clicking the green link, and entering your email address will automatically let you know every time there's something new to talk about. This year, we just released what plugs fuel filters rapidly, and 11 tips for keeping your equipment operating in cold climates.
Thank you for joining us, and please check out My Clean Diesel for any of the other webinars on related topics.